Hello children, this is Naresh Mathur. Today we are going to discuss chapter number 7, coordinate geometry. This chapter has 3 exercises which are based on 3 major formulas. First one is distance formula, second one is section formula, and third one is area of triangle. Let's discuss these formulas. But before this, let me tell you something basic of this chapter. As we discussed in the previous class, 9th class, we have also this chapter, the coordinate geometry. That chapter basically deals with the graph only, and these are the basic from that chapter also. The coordinates axes intersect each other at origin. In the 2D plane or the Cartesian plane, we have two axes, x and y. They are intersect at origin, whose coordinates is 0, 0, and the distance of a point from the y-axis is called as x-coordinate or abscissa. Similarly, for the y-coordinate or distance from the x-axis is called as ordinate. The coordinate of a point on the x-axis is always on the form x, 0 because at x-axis the value of y remains 0. Similarly, at y-axis the coordinates can be written as 0, y because at y-axis the value of x remains 0. A linear equation always represents a straight line on a graph, and a quadratic equation is always represent a parabola on a graph, as we discussed in the chapter number 3 and 4. Now this one is the formula. This formula is called as the distance formula. Suppose we are given 2 points A and B, and the coordinates of A is x1, y1, and the coordinates of B is x2, y2. Then the distance between the A and B point is given as whole square root of x2 minus x1 square plus y2 minus y1 square. Now taking consideration that any number you can take x2 or x1 because we are taking square of the difference, alright, so it will not make any difference in the answer. So this one is your first formula, which is quite important for you and new also. Now the sub formula for this, distance from the origin, obviously one coordinate will become 0, so the distance from the origin will be whole square root of x square plus y square. This is the second formula which we are talking about. This is called as a section formula. Section formula deals with when we have a line segment, let's say A and B, and whose coordinates are like x1, y1 and x2, y2 respectively, and suppose we have a point somewhere lying on AB. Let's say point P is lying somewhere between A and B, and this point P is dividing the line segment AB into M1 to M2 ratio. M1 and M2 are the numerical values. It can be 1:2, 3:4, or 5:7, and any numbers. So let's say P is dividing the line segment in M1 and M2 ratio. Then the coordinates of the P, let's say the coordinate of P is x, y. Then the coordinates of P will be, whose x coordinate will be defined as m1 x2 plus m2 x1 upon m1 plus m2, and the y coordinate will be defined as m1 y2 plus m2 y1 upon m1 plus m2. This is your section form. Alright, you need to remember this formula. Okay, just to remember 1 2 2 1 concept. M1 x2, m2 x1, and m1 and m1 plus m2 is common in x and y. Alright, similarly, if we have line A and B, and suppose P is the midpoint of AB. If the P is midpoint, then m1 is to m2 will be 1:1. Alright, then the m1 and m2 value of m1 and m2 will be 1. So the coordinate of midpoint of any line segment is given as x1 plus x2 upon 2 and y1 plus y2 upon 2. Just put the value of m1 and m2 1 in this formula, you'll get these values. Okay, this is the one more important formula. This is the third formula, area of triangle. Area of triangle means in which sense? Suppose we have a triangle on a coordinate system. Let's say on a Cartesian plane we have a triangle ABC, whose coordinates are a x1 y1, x2 y2 and x3 y3. So the area of triangle will be half of, in brackets, x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Just for simplicity, you can remember this. You have to put the value of x1, x2 and x3. Now learn this sequence: 1 2 3, then 2 3 1 and 3 1 2. Okay, x1 y2 minus y3, x2 y3 minus y1, x3 y1 minus y2. So by this you can learn this formula. One more important thing, this is called as modulus. Okay, we can use a bracket generally here, but these are the actually modulus. Modulus means what? Modulus always gives a positive value. Now area of triangle or area of any shape can't be negative, right? Now we are given triangle ABC. Now any coordinate can be taken as x1 and y1. Alright, you can take point C as x1 y1, and someone can take A as x1 y1. So might be possible you'll get a negative value. In that case, you have to convert that value in positive. Okay, that's why we use modulus here, because area of triangle can't be negative. Alright, and this is only a numerical value. Now if we are saying that the points are collinear, collinear means what? In a single line. So if ABC are collinear, means point A is lying somewhere on BC. It means area of triangle will become 0, because there is no triangle, so the area will always 0. The last concept, the coordinates of the centroid of a triangle is always given as x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. You know what is centroid is? Centroid is the intersecting point of the medians of a triangle. A triangle can have 3 medians. Alright, from any axis we can draw the median. So this point is called as centroid. Alright, the coordinates of centroid will be given as follows. Alright, so these are the basic concept of this chapter. Now we are going to discuss the first exercise, which is based on distance formula. Now just see how many patterns are there, or how many in ways we can use this formula. First question is given as find the distance between the following pairs of points. This is the direct question. We are given x1 y1, x2 y2. We just need to put this value in the formula and we will get the answers. 4 minus 2 whole square plus 1 minus 3 whole square, whole square root. So we are getting root 8. Root 8 can be written as 2 root 2. Always remember to write unit at the last, as we are finding distance, so we can write units. Alright, similarly second can be done. In third one, see a comma b and minus a comma minus b. So we are writing as minus a minus minus a. Getting my point? x2 minus x1. That's why it's minus a is coming, and similarly minus b. So we are getting minus 2a whole square is 4a square and minus 2b square equals to 4b square. Now suppose if we take this one as a x1, so we have to write a minus minus a. So it will become it will also become 2a, and we'll get the 2a square, we'll get 4a square. So we'll get the same answer. It doesn't matter in which sequence you are considering x1 and x2. Second question, find the distance between the points 0, 0, that is origin, and the 36, 15. We can find it directly. Alright, we have a formula x square plus y square, square root of x square plus y square. Now the second question is given as find the distance between the two towns A and B discussed as below. So this is actually the same question. We can find the distance between the two towns as, let's say this one is A town and this one is B town. So we can write the distance between these two towns is 39 kilometer. Alright, because it is given as a kilometer distance. So we can put B here, located at 36 kilometer east. This is the east, and 15 kilometer north. East then north. So point B will be here. Easy. Now third question. Determine if the points these and these are collinear. Now mention this concept collinear. Collinear means in a line. Alright. So if we have 3 points, let's say A, B and C. Alright. So if I am writing that A, B and C, and we have to prove that these points are collinear, then for this we need to prove that AB plus BC equals to what? AC. If this condition is satisfied by these 3 points, then we can say yes, these points are collinear. So just check it. Find the distance between A and B, we get root 5 unit. Distance between BC, we get 2 root 53 unit. And the distance of between A and C is getting root 265. So we are not getting this relation between these 3 points. So we can say yes, we cannot get a relation that one distance is equal to the sum of the other 2 distances, and the points are not collinear. Alright, just because we are not getting this relation, so we can say these points are not collinear. Alright. Next question says we need to check whether 5, 2, 6, 4 and 7, -2 are the vertices of an isosceles triangle. So it's quite simple. For an isosceles triangle, we need to find the distance of the all 3 sides. Sorry, it's not look like a triangle, but just consider this as a triangle. So we need to find all the sides, measurement of the all sides. We just find the distance between A and B and got root 37 units. We got the distance between BC, we got root 37 again. And the AC is given, we can find the distance between A and C point is as a 2 unit. So we can see the 2 distances are equal. Therefore ABC is an isosceles triangle. Alright. Similarly, in the question paper, you may be asked for a equilateral triangle, scalene triangle. Alright. Now we are given a condition. In a classroom, 4 friends are seated at a point ABCD. Champa and Chameli walk into the class, and after observing for a few minutes, Champa asks Chameli, "Don't you think ABCD is a square?" And Chameli disagrees. It means Champa is saying that it is a square, and Chameli is disagreeing that it's not a square. So we need to find who is correct. Just find the distance between AB, BC and CD and AD, and then we'll decide. So we just find the distance between AB, BC, CD and AD. So we can see all the distance are equal. So can we say till yet that ABCD is a square? No, it may be a rhombus also. Alright, all sides are equal, then we can say it may be a rhombus also. For this we have to check diagonals also. So if the all sides are equal and diagonals are also equal, then we can say that all sides are equal and diagonals are equal. Therefore ABCD is a square. Now the next point you need to remember that in a quadrilateral, you should know all the basic concepts of the quadrilaterals, whose diagonals are equal, whose not, whose all sides are equal, whose opposite sides are equal. Alright. Now the next question is on the same concept. We are given 4 different points and we need to tell which kind of quadrilateral they are forming. So in the first question, we are getting all sides equal and the both diagonals are equal, then we can say right, is a square, as we just done it before. In the second question, we are getting different measurements in all the sides. Alright, and we can see that AB equals to AC plus BC. Twice of root 13 is equals to root 13 plus root 13. It means it is satisfying the concept of collinear. And as the 3 points are collinear, it means there is no quadrilateral exist with these kind of points. Alright, so this is also an important question. You not need to confirm that which kind of quadrilateral they are making, or if they are not making, then you need to just check for the any kind of trick that we can say that they are not making a quadrilateral, just like as a collinear concept. Alright, the last one, we are getting the length of AB and CD equal and BC and AC is equal, so we can say opposite AD is equal, so we can say the opposite sides, both pair of opposite sides are equal. So it can be a rectangle, it can be a parallelogram. Just go for the diagonals, they are not equal, so we'll say it is a parallelogram. Alright, if the diagonals were equal, then we can say it is a rectangle. Alright, next question says find the point on the x-axis. Let the point be x comma 0 because it is on x-axis, so the value of y will become 0, which is equidistant from the point 2 comma minus 5 and minus 2 comma 9. Now it is again one more important concept, equidistant. Equidistant means what? They are at equal distance. Okay, let this point P is here, alright, and these points are A and B. Let's say A is here and B is here. So these are just equidistant, means the distance of AP is equal to distance of PB. It doesn't mean equidistant, doesn't mean that P is the midpoint of AB. Alright, so just find the distance of AP and PB and then equate it. You'll get the value of x, then we can put the value in this concept. So the minus 7 comma 0 is the required point. Getting it? Similarly, next question says find the values of y for which the distance between this point P and Q is 10 units. It's quite simple. We just need to use the distance formula. Just find the distance between P and Q. Let's say x2 minus x1, 10 minus 2, 8 whole square, 64. Y minus minus 3, y plus 3 whole square. So it will expand it by the a plus b whole square identity. Taking square both the sides, so 10 will become 100. Now we have a quadratic equation. Just solve it and get the value of y. So we have two values of y is minus 9 and 3. So two possible values of y is minus 9 comma 3. The next question is again on the equidistance concept. So if Q is equidistant from P and R, Q is equidistant from P and R, find the values of x. Alright, values of x. It means if x is having more than one value, then we have to find all the possible values. Also find the distances QR and PR. Alright, just find the distance between P and Q, applying distance formula. Distance between Q and R, applying distance formula. So from here we are getting x square equals to 16. So x is plus minus 4. We have to consider both the symbols. Alright, so it point can be 4 comma 6 and point can also be minus 4 comma 6. So for the both values we have to find QR and PR, for the positive 4 and for the negative 4. Alright, so this is also a important question. At last we are given 2 points. Find a relation between x and y such that a point xy is equidistant from the point 3 comma 6 and minus 3 comma 4. It is something like that. We have this point as x comma y and this one is equidistant from these points. Let's say 3 comma 6 and minus 3 comma 4. So you have to just apply the distance formula in both ways. First find the distance between this and this point. Okay, let this point is P and this point is A and B. So find PA and PB. Alright, so PA equals to PB. At the last we will get this equation. We need to find a relation between. It means it is asking for an equation. So at last, after the simplification, we will get a linear equation, that is the required relation. So I hope now we have discussed all patterns of based on the distance formula. So just try these questions, practice these questions. If you have any doubts, then let me know. I'll definitely help you out. Alright, thanks for watching, guys. Bye bye.